firstly, can I just say thank you for the opportunity to be able to come along and talk to you today. I just wanted one sort of admin point. It's made reference to renewable fuels in the opening heading of what I'm doing, but the original brief was actually to home in on wind energy, which is fundamentally what one of my clients has done. And therefore, the actual presentation has got a strong focus around wind energy and the link to health and well-being. One of the key things that's very clear in terms of the work that I've done to be able to pull this presentation together is there's not an awful lot of longitudinal surveys and assessments done in terms of the linkage between wind energy and health and well-being as such. I can go back to take you on a journey from 2007 through to 2018, 2019. And I'll endeavour to do that in the presentation to show you some of the thinking and some of the current thinking around the UK government policies and strategies aligned to health and well-being and how that overlaps into wind energy. The initial introduction is really based on two wind turbines that my client uses at their quarrying site at Brassington, the client being Longcliffe Quarries Limited. These two turbines are fundamentally the core renewable strategy that's on site at the particular location. There's two turbines, they're 2.3 megawatt turbines each. One turbine, admittedly, is limited to 1.7 megawatts of electricity as a result of the connection with Western Power that's been agreed, and they were installed around January 2016. They have the capability of generating electricity levels of around 60 to 70% of the site consumption. The client has recently installed a new wash plant, which has increased the usage on site and reduced the original level, which was around about 85% of site consumption when they were installed. There's a little bit of generation next to the turbines, a small parasitic load at what we call a Rider Point plant. And the turbines are maintained by the original provider, which is Enercon. The next sort of stage that I'd like to take you through is the introduction of sustainability concepts, because I think the way to try and present this linkage is to link health and well-being through 6 basic fundamental principles around sustainability. And these concepts are basic needs, which is fundamentally food, water, shelter, sanitation. I would include energy into those basic needs, and that's one of the ways that I want to link the concepts together. And then fundamentally health and well-being, health and education, which I'd like you to keep hold of education, if I may, because that thematic comes through the presentation quite strongly. Decent work also, same aspect comes through in terms of job security, job work, and then links to health and well-being. Resource stewardship, which is number 4 in the model, preserving stocks and natural resources. And of course, in this instance, we're using wind resource as the natural fuel to drive the performance of the turbines. Healthy ecosystems, it's a little bit thin in terms of wind energy in this one as such, but I'll endeavour to try and bring that into the presentation at the right time to show you any linkages that I feel is appropriate. And then the big one that you could argue is climate stability around limiting greenhouse gas emissions to the atmosphere, and obviously trying to keep us under the rise of 2 degrees. From a health and safety point of view, from a health and safety point of view, and I'm not electrical, Sarah touched on material science and metallurgy in the first instance, but I thought I'd give you a little bit of detail around some health and safety considerations around the turbines. The turbines themselves have a speed sensor that if the wind speed goes above, it's around about 22 metres per second, the turbines naturally change the orientation of the blades and technically shut down. So we don't overspeed, we don't overheat, we don't set them on fire. And there's a safety aspect around that, obviously. We generate, round about 615 volts. We're connected to a local substation at 11 kV. We have 16 amps per phase, and we're connected in a phase in a model called long-term parallel. And that's quite important in the sense that we don't have a lot of fancy switchgear on site to be able to provide the connection to the grid, because all this energy fundamentally at the moment goes to the grid, and the little parasitic load that I touched on at either point. All this protection requirement is done under G59-3, which was the model that Western Power obviously wanted us to connect to at that point under Section 10. It's changed to 99. G99 is now the current requirements, and there's some subtle differences around the switchgear. But at the point of install, it was G99. So we have some safety features around earthing requirements, voltage ranges, so we don't go over or under voltage from the turbines. Equally the same way, frequency ranges, rate of change in terms of the outputs of the turbines. The big control philosophy is around fault levels and the ability to ensure that we don't push fault levels too high within the constraints of the connection. The switchgear consideration I've touched on in terms of long-term parallel, and there's an aspect of ensuring particular loss of mains supply around the turbine. So there's quite a detailed element of safety considerations around the electronic and electrical install of the turbines. How does wind energy support then health and well-being? Well, I touched on number 6 in terms of the broad concepts is the climate change agenda. Principally, the turbines are zero carbon intensive. They're well recognised as being zero carbon. To try and put that into some context, if you're running a coal power station, such as one of the ones that we used to, or one of the ones that are physically in China at this point, coal is 937 grams per kilowatt of output in terms of CO2 emissions, roughly a tonne per kilowatt hour of output. If you take the UK model, and the cleanest gas that we have at this point in time with combined cycle gas turbines, we're around about 394 grams per kilowatt output electrical energy. So what I'd like to do in terms of taking you on this journey is bring in ecosystem perspective models. Ecosystem, we have 3 to maybe 5 elements in terms of what ecosystem perspective means. We have the term provisioning services, we have regulating services, and we have cultural services. And what I'd like to try and do is now bring in the linkage between the wind energy model to the health and well-being. In terms of ecosystem services, I want to really introduce you to this initial model. I quite like this model because fundamentally it's got the human dimension to it, and it's a closed loop model. One of my main clients takes the mickey out of me because I talk about anthropogenic carbon in terms of man-made carbon. But fundamentally, I think the linkage obviously from wind energy through to social health and well-being has to pass through this typical type model that says what's the impact on humans and what can humans do in turn to close the loop to ensure that we get healthy ecosystems. So what I'd like to do at this point is just move you to the left-hand side of the model. And I've got to use my pointer here, I'm afraid, to be able to guide you where I'd like to take you through on the thinking. The first thing effectively on the provisional service is this term fuel wood and the generic resources that we touch on at the bottom. The generic resources, of course, is the wind energy. Normally under fuel wood, we have the term energy services. So fundamentally, I see wind energy providing provisional services under the ecosystem model. And then if I walk you through this model left to right, we have the term regulating services I touched on, and we have this term climate regulation, which was number 6 on the broad spectrum of the 6 sustainability concepts. And I would ask you to hold these things in your mind. So hold the energy under provision, hold the climate regulation under regulating services. And then we start moving into the cultural aspects of the model, which is obviously people orientated. And this aspect is around the education, which I think the educational piece around wind energy is one of the ways that we can help health and well-being, including the sense of place and fundamentally cultural heritage, because I do believe that when you install wind energy turbines, your attitude towards certain aspects around cultural issues then starts to change. If we then move to the right-hand side, to be honest, it starts to get a little bit thin in terms of the linkages. The first obvious one, though, that I'd like to draw your attention on is restoring services down here where we have air quality. Air quality is quite clearly, in my book, enhanced by wind turbines. And I'd like to just show you a little bit more about that linkage as we go through the model. When we start looking at protecting services, enhancing services, it then starts to really get into the green environment. And the green environment with wind energy is very much determined by the developer in terms how he conducts his strategic assessment and his environmental assessment and how he deals with the land bank and the associated design of the wind farm in terms of space between the turbines and overall layout. So there are linkages, but I feel in terms of health and well-being of individuals, people, it's a little bit thinner. There's one final point I'd like to guide you to, which is this little acronym here called TEG. It's kind of hidden, but it's fundamentally technical and knowledge sharing and educational sharing services on the right-hand side of the model. So again, under the model that we touched on before with the 6 basic concepts, I'd like you to keep that equally in mind. So how does wind energy then add value in terms of health and well-being? Well, we've touched on clean energy. We've touched on climate regulation. There's no doubt that wind energy helps to slow down global warming to a point, and I'll expand on that a little bit later in terms of the presentation. Improving air quality, certainly. Educational support and cultural support, and driving new behaviours. So the provisional services that we touched on, through to the regulating, through to the cultural, very definitely for me, I think I can show you some linkages in the models that I will share with you. What's the takeaways at this point? Well, the takeaways at this point is very definitely around fundamentally the basic needs that we touched on: climate stability, healthy ecosystems to a point, but wind energy also provides decent work, and decent work is number 3 in terms of the sustainability concepts. Resource stewardship we touched on in terms of wind resource, and then ultimately trying to link this to health and well-being. So how do these linkages look? Are they strong? Are they weak? What exactly do these linkages look like? And a very honest appraisal of this is it took quite a bit of research to be able to try and trawl out what I thought were viable and assertions that I could make to you that had a bit of confidence behind them. The 2 particular wind turbines that we made reference to earlier they do effectively remove approximately about 2,500 tonnes of CO2 equivalent per annum. So there's obviously a direct linkage there to climate stability and climate change. So that's a clear linkage for me. And that obviously helps with global climate change mitigation around avoiding the extreme weathers, the droughts, the floods that we have under what we would recognise as climate change impacts. There is no pollutants fundamentally, and therefore PM10, PM2.5, which is the one at the moment that the UK government is starting to really home in on, and PM1, which is the one that the NHS and Natural England and the health authorities would like us to try and manage better. There's no doubt for me in my mind that the clean air that the wind turbines give is also a natural benefit. There's no combustion. There's no combustion of fuels. We have no NOx, and we have no SOx emissions using wind energy, and I'll expand on this later in the presentation. We don't burn waste. We don't burn recycled materials, so we don't have dioxins and furans getting into the atmosphere. However, with wind turbines, there is a but. We do have noise. We have noise around 40 to 50 decibels at ground level, and we have noise around 100 to 110 at the nacelle at the top of the column. It does depend a little bit on the design, whether it's current design in terms of direct drive, or the earlier designs back to the 2007 period I touched on, where we had the gearbox issues. Avian mortality, yes, we have bird strikes, we have back strikes, unfortunately. So there is another downside in terms fundamentally of the technology. And I thought I'd share this one because this one made me sit up. 0.15 million strikes in the US in a given year, which seems a very, very sort of high number for me. The land-based footprint is in debate at this particular point in time. Obviously in the UK, we have a relatively low land footprint relative to, say, the US. In the US, there is some data sets which show that the footprint, or suggest that the footprint should be bigger than fundamentally they've been designing over the period. We can have visual and we can have aesthetic issues associated with wind turbines. And again, I'll expand on that a little bit later as we go through the presentation. Visual impact, fundamentally, this happens with the movement of the turbines in the main. And there are ways that you can try and help with visual impact, which includes colour coding of the towers. Normally, with a UK background, we kind of grey the towers out for the obvious reasons, but there are ways and means of trying to manage visual impact. Shadow flicker, equally, there's ways and means in which we can manage the shadow flicker, fundamentally through sensors that are on the turbines that just changes the orientation of the blades. And the ideal there is to try and minimise that when you're actually looking at the turbines from a distance. In terms of residential distances, given where we place turbines in the UK, model fundamentally, this is quite a big important issue. Residential distances using GIS technology, where we can actually measure the distances of the local population, and things like migration paths of birds, all these become quite important in terms of the development of the model, with the link to health and social well-being for the residents within the catchment area. There's still a but. Power density ratio for wind turbines is relatively low compared with solar power, which is a higher density ratio. And in some instances, clients choose which way do we go? Do we go the wind route or do we go the solar power route? For those sorts of reasons. Again, back to US studies, I think there's a little bit of a polar view in certain things between ourselves and the US. They have quoted in the early days an interaction with atmospheric temperature and sort of pressures around the turbines. On average in the States, they're claiming that there's a local temperature increase of 0.24 degrees C. I haven't seen that model, frankly, for the UK. So I'm not 100% sure whether that applies to the UK, but certainly in the US, they have that aspect of their thinking. So, in other words, sort of high-level key drivers, yes, I've touched on the greening aspect. I've touched on some drawbacks. I've touched on many aspects of what wind turbines do for us in terms of giving us good outputs and effectively then trying to link it to health and well-being. The one thing that I did find was British Medical Journal, who did a report, not a long-term report as I touched on before, a short-term report on 40 to 50-year-olds, fundamentally assessing things like noise, aesthetics, coping strategy, which was quite an interesting aspect of how they looked at this. And in terms of one of the many aspects, which I do think does to an element go unnoticed under health and well-being, is the social employment that the sector provides and the self-enhancement and the self-belief that that gives individuals within the sector. This is fundamentally main output from the BMJ findings, and if I could draw your attention down to the bottom aspects of the model, where we are looking at self-related health, around 33% actually made reference to feeling negative impacts as a result of the turbines. 50 to 60% definitely could relate to noise, and therefore they felt that it was noise sensitive, that there was increase in noise, partly because it's rural, partly because fundamentally the background noise was relatively low in the region they were. These turbines were about 800 metres away, but there's definitely some aspects around negativity in terms of the feedback of the turbines there. Overall, what I'd like to sort of guide you to is there is a risk of annoyance with these turbines. And in certain rural areas, the noise level perception gets higher and increases. One of the key ways to mitigate this is around social inclusion, which came out in the report feedback from the British Medical Journal, which was to involve the public in the design strategy around these turbines and get them ultimately involved in the project as much as possible. So what's the takeaways? Well, these are the key takeaways in terms of what I think is linkage that I'm comfortable in sharing with you. Yes, I do feel that the turbines limit global warming. Yes, I do feel that they provide clean air. They do provide jobs and skill resources. And there's some good motivational factors that can link it to health and well-being. Yes, there could be a damage to diversity if it's not managed well. Yes, there's some noise and visuals, but again, the developer of the site has to do the appropriate environmental studies, strategic studies, and the right design. Wind energy is dispatchable. We have scenarios where there is no wind, of course. So technically, they're called dispatchable technology. And I actually think that they sit best alongside other technologies in terms of their overall performance. That could be battery. It could be hydrogen now, which is becoming the model for green hydrogen, or one of the models for green hydrogen, where we have renewable energy from turbines feeding electrolysis plants to provide hydrogen. In the detail, in terms of climate change, I've touched on the carbon model, but in clean air, the Public Health England quote 29,000 deaths from PM 2.5 per annum in the UK and 23,500 based on NOx. I've got a extra zero in there, apologies. 5% of UK deaths are associated with poor air in the UK. In terms of green recovery, it's certainly helping increase jobs through to 2023, where the numbers have indicated. And then fundamentally, the UK Environmental Plan, which came out just literally a couple of years ago, pushes noise, air quality, low carbon and tranquility to help increase health and well-being. If we manage those properly through the wind turbines, then I do feel we can get a strong linkage to enabling health and well-being. Finally, and I'd like to leave you with this, is just this new model, which has literally just come out in the last year. This does show a linkage between strong economy, improved health and well-being. On the left-hand side of the model, the climate change, the resource efficiency, the pollution, everything that wind energy for me promotes, through to aspects around atmosphere, the linkage to human capital, around labour and education, pushing through to clean air, and then fundamentally products from natural resources, which fundamentally the wind turbine delivers. So therefore, I'm comfortable with those assertions. So if I may, I'd like you to leave with this slide in mind, plus those 6 sustainability concepts that I touched on previously. So I think that is my time up. So thank you very much for listening. Thank you.
We have got a question on wind power assessments, actually, Bob, if you've got a minute to answer it quickly now.
Yeah, I'll try.
Is it permissible? Is it not permissible to look at how wind power generation is offsetting the environmental impact of traditionally generated electricity like coal?
It's certainly part of your strategic environmental assessment that could be done, because you could fundamentally compare it. Whether you can do that physically now with the coal model that's in the UK is maybe a question. Certainly on a global basis, you could certainly compare it. That 935 figure I gave earlier in the presentation, grams per kilowatt hour of output. There's some current numbers globally. They're not necessarily the UK model fundamentally. Okay, but you could certainly compare with traditional burn technologies, whether that's an energy from waste plant or technically a coal plant, depending whether it's got carbon capture and things like that on the plant, because there's certain plants now that if they're over 300 megawatts of thermal energy, they automatically have to have carbon capture. So like everything to do with sustainability, there's a tension there and it depends, okay? But certainly worth a look in my book, depending on the geography, I would argue, in the landscape that you're physically looking at in terms of the country specific. Okay.
Perfect, thank you very much. Follow up. Surely there are also impacts upon birds and noise impacts on neighbours of living near a traditional burn power station.
I've got an energy from waste background, and equally so. And under the environmental impact assessment for those models, all those aspects need to be taken into account under your environmental assessment. So whether it be a power station as in traditional burn or a new burn in terms of waste energy, or indeed, obviously, the wind energy scenario, your environmental assessment should cover all of that. So I completely agree with the last statement, yes.
Perfect.